Today's topic is rational and irrational numbers. I can perform operations with rational exponents. I can determine if an expression represents a rational or irrational number. For the vocabulary, I want you to refer to your number system graphic organizer, and I want you to list 3 examples of irrational and rational numbers. Example 1 is a review of fractions. When you are adding or subtracting fractions, you need a common denominator. The denominator is the bottom numbers. Our first example, we have a denominator of 6 and 3. I can make them a common denominator if I change the 3 to a 6 by timesing it by 2. Whatever you do to the denominator, you need to do to the numerator, the top number. That gives us 4 6 plus, now 2 times 4 is 4, 3 times 2 is 6. Now our fractions have a common denominator. I can add the numerators, the top numbers. 4 plus 4 gives me 8. The denominators stay the same at 6. If you can simplify your fractions, please do. 8 6 simplifies down to 4/3. When you multiply fractions, you just multiply straight across. These are the easy ones. Multiply the numerators, multiply the denominators. 1 times 5, 3 times 4. I can't simplify 5 over 12, so I'm going to leave it. Dividing fractions, you're going to take the reciprocal of the second fraction, then multiply. Reciprocal of the fractions where you flip it upside down. So if I do this, I'm going to have my 1/4 times, now the reciprocal, 7 over 2. Now we're just multiplying like we did in the first example. 1 times 7, 7. 4 times 2, 8. Example 2, we're going to work with rational exponents. The exponential property rules still apply. We're just dealing with rational numbers. For the first one, we are multiplying 2 exponents, and we know the rule is when you multiply them, you add their powers. So the power of 6/5 plus 3/2. Well, for adding, subtracting fractions, we need a common denominator. A common denominator between 5 and 2 could be 10. To make the 5 into a 10, I'm going to times by 2 and times by 2. For the 2, I can times that by 5 and times the top by 5. So my new fractions are going to be x to the 12/10 plus 15/10. I can add those and my answer will be x to the 27/10. Our next example is dividing exponents. When you divide exponents, you subtract their powers. The top power minus the bottom power. Again, I need to find a common denominator. I can make the 3 into a 9 by timesing it by 3. So my new fractions are going to be 7/9 minus 24/9. If I subtract those, I'm going to get b to the negative 17/9. We don't like leaving our answers with a negative exponent, so I can rewrite it as a positive exponent by putting it in the denominator, putting a 1 on top. Example 3, solving using rational exponents. I want to get x by itself. I'm going to take x, now written as a radical, and rewrite it as a rational exponent. Using our fun saying, power to the tower, roots underground, I can rewrite it as x to the power of 3, root of 4, so x to the 3/4. I still need to get x by itself. One way I can do this is raising it to the power of the reciprocal. The reciprocal of 3/4 is 4/3. So if I raise it to the power of 4/3, let's see what happens. Power to a power, we multiply. So if I multiplied straight across, I'd have 3/4 times 4/3, which would give me 12 over 12, which equals 1, which cancels the exponents out, leaving me with just x. Whatever I do to one side of the equation, though, I must do to the other side. I need to raise the 125 to the 4/3 as well. What I have now is x all by itself, equaling 125 to the 4/3. Now I need to focus on simplifying 125 to the 4/3. I'm going to go back to writing it as a radical. 125 is the radicand. Power of 4, root of 3. Now this looks like it'd be a very large number, but let's write it out a little bit differently. I'm going to write it as 125 to the 4th power. That means 125 times 125 times 125 times 125, 4 of them. If I actually multiplied 125 by itself 4 times, I'd end up with a gigantic number. Instead, I'm going to leave it and notice that I have 3 of a kind. I can bring out 125. Now I'm down to x equaling 125 to the cube root of 125. Much simpler. I can still simplify this further because 125 can be broken down to 5 times 5 times 5. We have another set of 3. Taking out the 5, if I multiply those two, I end up with x equaling 125 I took out originally times the 5 I took out from here, give me 625. Example 4. Determine whether an answer is rational or irrational. In our example, we have 1 plus the cube root of 10 squared. We want to see if I added those two together, would it be a rational or irrational number? Let's start with the 1. We like the 1 because it can be written as 1 over 1, which makes it rational. So the 1's rational. But what about the cube root of 10 squared? In its form, it's kind of hard to tell if it's a rational or irrational number, so let's simplify it. Cube root of 10 squared, I can rewrite that as 10 times 10. I still need to simplify it because I can't take anything out, so cube root of 2 times 5 and 2 times 5. Still, I don't have any groups of 3, so I can't simplify the cube root of 10 squared, which leaves me to say it's an irrational number. So if I have a rational number plus an irrational number, I will still end up with an irrational number. Lesson recap. Can you perform operations with rational exponents? And can you simplify expressions and understand the difference between a rational and an irrational number? If you need help, rewatch the video, look up the other videos, or come in for help.